No one buys servers anymore. Every new technology company being built right now is on the cloud. Previously tedious operations and workflows are now much easier to perform on Google Cloud. Traffic splitting lets you switch between your app versions without downtime. Object lifecycle management allows you to configure automatic file deletions when they meet certain conditions. Then the combination of App Engine and Cloud Tasks help you scale up and scale down your server capacity to handle huge workloads without breaking a sweat. What you should know before taking this course is that you should have at least some experience building web applications. But a lot of the examples that we go through will be using the Node.js programming language, so the examples will be easier to grasp if you're already familiar with it. It would also be good if you're already familiar with how to connect to an SQL database. Now, you don't need to know how to set up a CI/CD pipeline. Just understanding what the CI/CD pipeline is good enough. And that's it, Google Cloud website. It can be found in cloud.google.com. This is where we can see a ton of information about GCP's products and services. The links at the top are the most important links in GCP. Why Google gives us information on what makes GCP special and why it's a great choice to use Google Cloud. Solutions give us many examples of how to use Google Cloud products in specific industries and also grouped into other common categories like digital transformation and others. Products, on the other hand, shows us all the products and services available in GCP. As you can see, there are a lot of products. So they've been grouped into categories like compute, storage, and so on. The pricing link gives us pricing details on all the products, including this really useful link to a pricing calculator, which lets us estimate our total costs depending on our estimated usage of multiple GCP products. Getting started points you to various resources on how to get started with GCP. Pretty straightforward. Now, the last three items are my favorite ones. Docs gives us links to all that detailed documentation on GCP products to help us in our time of need, or when we simply want to understand how things work. It's all in Docs. Now, if it's not in Docs and we still need help, then there's support. This links to the Support Hub, where there's information on how to contact Google Cloud, and also talk to experts to get the help we need. And lastly, there's the sign in link. Let's go ahead and sign in. So I enter my email, my password. To get started, let's press this Go To checklist. So now we see the starter checklist. Now, depending on your account, you may see some of these already checked or none of them checked. The first step is to create a billing account, which I have already done. If you have not done that yet, then you can click on this one. Go to billing and set up your billing details. There's also an automatic free trial that you can take advantage of. The next thing we do is to create a project. Let's do that. Let's press this Show Me button to show us how to create a project in GCP. And there it is. We can create a project by pressing this button in the top navbar in the console and then pressing New Project. Let's give our project a name. My Pet Project. We also get an auto-generated project ID and also options for setting organization and location. We will stick to the default values for now. Let's press Create. Now, our project is being created and should take a few seconds to complete. And it's done. Our new project is ready to use. We click it and we're taken to the project dashboard. And that's all we need to get started. Google Cloud Console. It is our command center for Google Cloud services through a web browser. First, we have the dashboard. The dashboard is made up of these things called cards. Cards show useful information relevant to our GCP account and project. Let's go over some of these. For example, the first card over here shows our project information, like our project name, project ID, and project number. It also gives us a quick link to add people to our project or adjust our project settings. Another card shows the different resources our project is currently using. Now, all developers want a fast application. The trace card pulls information from GCP Stack Driver and shows requests with high latency, so we can quickly identify bottlenecks in our app. There's even a Getting Started card. It's here to help us get started. It shows links to various tutorials that helps us with our GCP journey. Since we're already familiar with these items, we can hide these cards. This way, we can customize our dashboard to contain only the cards we find useful. By default, we have cards that show us charts from various services that are active in our project. For example, here we have App Engine, Compute Engine, SQL, and APIs. Now we can customize this if we want. We can add other charts that we want to be visible in the dashboard. For example, let's try adding a chart that shows us the memory usage of our App Engine application. Let's add a metric, system memory usage. Let's press save, and there we go. Another card here simply links to the Google Cloud Status dashboard. This shows each GCP service status, whether it is up or having downtime. So if there is any issue with any GCP service, it will show up here. The billing card shows our current estimated charges for our entire billing account. Now, every software that is being used will have errors. What's critical is that we find out what these errors are right away. The error reporting card shows us the top errors within the past 24 hours so that we can immediately address issues in a timely manner. Finally, we have the cards on news and documentation. We can learn more about the latest news on GCP as well as reference documentation when we need to. That's the dashboard. Now let's move on to the list of all products available in Google Cloud by navigating to this hamburger menu on the upper left of the console. Here, we can see all the products and services in Google Cloud. They are grouped into categories like artificial intelligence, big data, tools, operations, networking, storage, compute, and a generic category. That's a lot of products. To make it easier to reach our most used products, we can pin them. It will bring it up to the top part of the products list where all the pinned items are also shown. That's how we navigate between products and services in GCP. Now, let's talk about how we switch between different projects in GCP using the Resource Switcher. Clicking the Resource Switcher brings up a pop-up where we can browse all our projects within our organization. We can also switch between organizations. We can search for projects and folders. Or we can just select the project from the recent or all list. This is also where we can create a new project for our account. Now the three dots over here bring up additional links to manage our resources, set IAM permissions, settings, and manage our organization policies. Let's try switching to another project in our account. Let's click the project we want to switch to. And that's it. The search bar over here lets us search for anything in GCP, whether it is a project or a service or an item within a service. We can just freely type exactly what we are looking for and it will be brought up so we can quickly access it. Let's try searching for a specific App Engine version, for example, like v4-small button. And there it is. Or let's try searching for the BigQuery service. And there it is as well. And that's basically all we need to know about the Google Cloud Console. A lot of commands are more appropriately run from the command line instead of a graphical user interface. That's what Google Cloud Shell is for. It's a command line interface that is readily accessible from a web browser. To use Cloud Shell, let's go to the upper right of the Google Cloud Console and click this Activate Cloud Shell button. While we are waiting for it to launch, let's talk about the specs of the Cloud Shell. It launches a Linux terminal on a virtual machine. This virtual machine has about 5 GB of storage and has 1.7 GB of RAM and 0.5 virtual CPU. The Cloud Shell comes free with your GCP account. Also, these specs can be boosted for a limited time when necessary. Now that it's launched, you can see that it's really a Linux terminal. But the most important part is that it comes pre-configured. Let's run gcloud config list. It comes pre-configured with your project credentials, so you don't need to set up all of that. It also comes with the latest version of gcloud. It also comes pre-installed with common programming languages and tools such as PHP, Python, Node, to just name a few examples. It also comes with infrastructure tooling such as Docker and Kubernetes. Basically, we just launch Cloud Shell and we go straight to doing what we want to do. The setup has been taken care of for us already. Another extra feature of Cloud Shell is customization. For example, we can change the look and feel by switching between dark mode and light mode. We can also change the font size, the font style, and for convenience, we can also set the copy command to automatically activate whenever we highlight a segment of text. When it comes to editing files in the Cloud Shell, we can use a standard Vim editor that comes with Linux. Or we can opt to use a text editor that's built into Cloud Shell. The editor provides an interface that is easier to use when editing files within Cloud Shell. Let's try creating a new file in the editor. Let's call it index.html and give it some text inside. Hello, GCP world. And let's save it. Now let's switch back to our terminal and run the list command so we can see all the files in our current directory. As we can see, our newly created index.html file is there. Another feature of Cloud Shell is called Web Preview. We can use Web Preview to access selected ports of our Cloud Shell VM through the web. To test this, let's start a simple Python web server that will serve our index.html to the web through port 8080. To access it through the web, let's click on Web Preview and select Preview on port 8080. This will open a new window where we can now see our index.html being served. Great! If we need or prefer a port other than 8080, we can also choose from a predefined list of ports by clicking on Change Port and choosing the specific port. There you go. The Cloud Shell gives us quick yet powerful access to GCP from within the browser. This is really useful when we need to get something done quickly, but we don't have our local terminal set up yet. Just open a browser, launch the Cloud Shell, and we're good to go. Google Cloud SDK is also known as gcloud. It's basically Google Cloud's command line interface tool. You will find yourself using this tool in order to execute commands or make configuration changes to GCP. So it's best to familiarize ourselves with the gcloud tool. We'll start with installation, then we'll also learn how to make some configuration changes. First, let's follow the installation instructions in this page. I'm using a Mac OS over here, but there are also options for Linux and Windows as well. For Mac and Linux, we copy and paste these commands and run them in terminal. First, let's run the installer script. This basically downloads the installer and runs it. Let's wait for that to finish. Now, whenever we encounter a prompt throughout this installation process, we'll just hit enter to select the default option, like this one. Press enter. Press enter again, and now it's installing the components. Let's press enter again, and enter again. Now that it's done installing, let's go back and copy paste the next command. This one basically restarts our shell. And finally, we're now ready to initialize our G-Cloud environment. Let's do that by running gcloud init. For this one, let's press 1 to use this configuration with new settings. It will try to authenticate with our account in Google Cloud. Let's press enter. Let's just enter our credentials and follow the prompts. Allow. Once done with the login flow, let's go back to the terminal and see that it's already been authenticated. Great! Now G-Cloud is asking us to pick a project to use. Let's go with the first one. Let's press 1 and enter. Let's press yes for this one. Now we have to enter the default region and zone. I'm going to enter US Central 1A over here at number 8. I'll go ahead and press 8 and enter. For you may select the region and the zone that makes the most sense to you. Usually, you would select the region and zone that is the closest location to your users in order to keep your latency really low. Alright, now that we have our basic configuration set, let's try to change some of the settings. If we type gcloud config list, then it's going to give us the properties that have already been set. So let's add gcloud config list -- all so that it shows us all the possible configuration options. As you can see, there are a lot of properties that we can set here. One thing to note is that the options are divided into sections. For example, we have here proxy, Redis, run, SEC, secrets, spanner, and so on. In order to set a configuration, we have to run gcloud config set, then add a section, in this case Redis / region, which is the property, then the value we want for it, which in this case is US Central 1. Now let's run gcloud config list again. As you can see, our new configuration has been added. Great! There are 3 main Google Cloud SDK CLI tools. First, we have GSUtil, which is for Google Cloud Storage. Then we have BQ, which is for BigQuery. And finally, gcloud, which is for the rest of Google Cloud. In this video, we will focus on gcloud. Let's go back to our terminal and let's verify that we are logged in by typing gcloud auth list. As you can see, our email address has an asterisk to the left of it because it's active. We can have multiple authorized accounts and we can switch between them as well. Now there are 4 main things to learn in gcloud: command groups, commands, configurations, and properties. A command group is like a menu with commands or more command groups inside it. To see the first level of command groups, let's go back to our terminal and type gcloud. Now we can see all the command groups available to us. Let's pick one, say AI platform. First, let's press Q to close this list and let's type gcloud AI platform. Now we are shown the command groups available inside AI platform, as well as the commands in this group, in this case, predict. We can also type -- help to the end of any command or group to get more details in the context of that command or group. Let's try gcloud AI platform -- help. This gives us more details into what are the flags, groups, and commands available. Now let's talk about a special set of command groups called alpha and beta. The alpha and beta command groups contain commands that are still in alpha or beta. These commands may change in the future, and that's why they are separated. For example, let's compare the available commands for the AI platform. Let's type gcloud AI platform. And let's also try gcloud alpha AI platform. As you can see, the alpha group has a new command group called locations that is not available yet in the general command. The alpha and beta command groups allow us to access these. Lastly, we can set and unset configuration properties. We do this with the command group gcloud config. Here, we can see how we can set or unset the values of our configuration properties. We can see the properties that are currently configured by typing gcloud config list. These are the properties set in the current active configuration, which in this case is the configuration named default. A configuration is basically a set of defined properties. Let's check our configurations by typing gcloud config configurations list. We can have multiple configurations and switch between them. This is useful when you have different projects and different sets of properties. So you don't have to set and unset each property. You can just switch between configurations and all the properties of that configuration are carried along with it. Alright, gcloud is huge, but by using command groups, commands, and properties, and our very useful -- help flag, it'll become really intuitive to navigate and manage GCP, even from the command line. Now we're going to learn how to deploy a simple application into Google App Engine. App Engine supports many languages like Go, PHP, Java, Python, and many more. But for this example, we are going to use Node.js. App Engine has two types of environment, standard and flexible. The main differences are listed here. The standard environment is more opinionated and optimized for running on Google Cloud. It's faster to deploy and also can scale down to 0 servers. However, the trade-off is it's less flexible and less portable to other platform providers outside of Google Cloud. For this example, we're going to go with standard. Here, I have a simple Hello World application written in Node.js. The really important files we need to have are app.yaml. App.yaml contains our App Engine specific configuration. We set the runtime property to Node.js 10, which is a specific version of Node that we're going to use. You can change this to the specific language and runtime you are planning to use. For example, Node.js 12, Python 37, or Go 112. There are many other properties we can set here, but runtime is the minimum requirement. Next is package.json. It contains standard package.json stuff. On line 16, what's important is that the start script is running node app.js. This is the script that App Engine will run when our app is serving requests. Now, let's go to app.js. This is a basic Node app using the Express framework. As you can see on line 8, we're simply going to output Hello World. The important parts here are in lines 13 and 14. Our app listens to the port number provided by the port environment variable. We can default to port 8080, but our app needs to listen to the port environment variable provided by App Engine once it's already deployed. Let's try running our app locally. Let's open a terminal and run npm start. And our app is now running in localhost 8080. Let's visit the link, localhost 8080. And tada! Hello World. Great! Now let's try to deploy our Hello World app online on Google Cloud. For this, let's go back to terminal and we use the command gcloud app deploy. Before we do that, let's Ctrl+C to quit and let's type gcloud app deploy app.yaml. Alright, we press enter and it's now deploying. This will take a minute or two, especially on the first deployment. Okay, now the deployment has completed. Let's check out our app online using this link. And hello world! Great! That's all it takes to deploy an application on Google App Engine. By default, App Engine applications are given a subdomain of appspot.com that is accessible to the web. But what if we want to have our own custom domain name linked to our application? We can do that by setting up a custom domain for our App Engine application. To do this, we go to the App Engine product page in the Google Cloud console. Inside the App Engine menu, we navigate to the settings page. In the Settings page, we select the Custom Domains tab and open it. There are two options for adding a custom domain to our App Engine application. The first one is to link a domain that we already own. The second one is to register a new domain and link it to our app. We will go through the first option. Let's link a domain that we already own. Let's click on Add a Custom Domain. There are 3 steps to this process. The first step is to select the domain we want to use. Since our domain is not in the list, we select Verify a New Domain and we type in our domain name, socialnetworkforpets.com. That's our domain name. And then we press the Verify button. This will open the Google Webmaster Central Verification Console. This is what Google uses to verify that we are the owner of the domain name we are going to link. If your domain name registrar is in the list, you can select it. If not, you can choose Other. I will choose Other. This will open custom instructions on adding a text record to our DNS records for the domain name we want to link. Let's go ahead and copy that. And let's open the DNS records for our domain and add a text record. Text record, and let's paste that, and let's press Add Record. Going back to Webmaster Central, let's press Verify. Now most of the time it takes several minutes for the DNS records to propagate, so we will have to wait a few minutes and keep on retrying. You can always leave this page and come back to it every few minutes to try again. The verification text doesn't change, so it's okay to retry, and we don't have to copy-paste new text records. Once it succeeds, like this one, we can now go back to the App Engine Custom Domains form and select our verified domain name. Let's press Continue. The next step is to choose the domains and subdomains that we want to map to our app. Usually, it's just the main domain and the www subdomain. You can add whatever subdomain you want and also point it to your app. Press Save Mappings and Continue. Now Google Cloud will give us a list of DNS records to add to our domain in order for the custom domain mapping to be completed. To save time, I've already done that ahead, and you can see all the additional DNS records here. Since we've configured that already, let's go back and press Done. And see how Google is automatically setting a managed and auto-renewing SSL certificate so our site will be able to serve HTTPS traffic without us having to do anything else. No need to link or renew certificates. Google will take care of it automatically for us. This setup process takes about 15 minutes to complete. Now, let's visit our new domain and see if it shows our app, socialnetworkforpets.com. Our app is now live and accessible through our own domain name. Perfect! Alright, now let's explore how to configure HTTPS by using our own SSL certificates and securing our App Engine custom domain. Here are the steps in the Google Cloud documentation on how to do this. First step is to verify our custom domain, which we already have. Second, we need to disable the default Google Managed certificates. Let's go ahead and double check that that's the case already. We'll go to App Engine, Settings, and Custom Domains tab in the Google Cloud console. We can check all of our custom domains and try to press Disable Managed Security. In this case, it's already been disabled, and that's why this button is not clickable. We can also verify by looking at the SSL security and seeing the non-values for both domains. Next, prepare your SSL certificate files and private key. I have mine here inside this folder. We have the private key and the SSL certificates. Next, we have to convert these files into the format that App Engine supports. Let's click on this link right here to get more instructions on that. First, let's convert our private key into an unencrypted PEM format. Let's copy and paste this command and replace the details with ours. Let's hit enter, and there we have it. Next, let's concatenate all of the certificate files into a single file. Let's copy and paste this command and let's replace it with our details. Let's hit enter, and there we have it. It's important to double check that the end certificate and begin certificate statements in line 38 are on their own lines. In this case, let's enforce a new line and save. Now before we continue, it's important to verify that our SSL certificate and private key match. Let's run this command in terminal. As we can see here, they output the same string. We're now ready to upload these files into App Engine. Let's go to App Engine Settings and then SSL Certificates. Let's press Upload a new certificate. Then let's put our PEM public key certificate over here. Let's select our certificate. And then let's put our PEM private key. And then let's press Upload. Alright, our SSL certificate is now ready for use. All that's left is to assign this to our custom domain. Let's assign it to our domain and press Save. And that's it. Now let's verify if it's working. Sometimes this can take a few minutes to take effect. Let's visit https://socialnetworkforpets.com, and as you can see, we now have HTTPS enabled. Let's click on the HTTPS details, and as you can see, it's now using our custom certificate. So that's how you set up a custom SSL certificate on a custom domain in App Engine. Before we dive deeper into App Engine, it's really important to understand the components that make up an App Engine application. At the top level, you have a Google Cloud project. Each Google Cloud project can only have one App Engine application. However, an application can have multiple services. A service works like a microservice. An App Engine app can work fine with just one service. However, if you have a large application, you can separate logical components into their own services. For example, you can have one service that handles front-facing user and API requests. You can have another service to handle batch processing and pipeline-like operations. And you can have another service for admin panels dedicated to admin and internal users. Each service can have multiple versions. A version is basically a new deployment of your service. Like version 1 as your main, then version 2 where you have some bug fixes, then 3 and 4 where you are A/B testing some adjustments. Now there are special tools in App Engine that let you gradually roll out versions, roll back, and even serve traffic on multiple versions at the same time. Each version can have multiple instances. This is used for scaling capacity. The number of instances can scale up and down automatically or manually, depending on the configuration, to handle changes of load on the application. Let's go through all of these in the Google Cloud Console. Let's go to App Engine, Services. Here, you can see all the services in our app that we've made right now. Then here are all the versions under each specific service. Then here are all the instances under each specific version. And you can see all the requests that each instance has recently handled and its recent QPS rate. Each component in App Engine can actually be reached through its own unique URL. The default service can be reached through the project ID followed by the region ID .r.appspot.com. For example, pet-project-285907.df.r.appspot.com. We can reach a specific service by adding the service ID, in this case, admin. And further, we can target a specific version by adding the version ID as well, in this case, v1-admin-panel. Omitting the service and going straight to the version also works. In this case, it will just use the default service. That's how we target different components using the URL. And that's all you need to know about App Engine components. Component-specific URLs are quite useful, and we can use this to our advantage for creating multiple environments for testing features before they are deployed to production. What I'm about to share is a little bit opinionated, but this will also show you how we can use component-specific URLs to make testing more streamlined. When working in real-world applications, we usually deploy our application first to a testing or staging environment where it is tested by our QA team and accepted by product owners, before it goes to our production environment where it serves real users. We can create a similar setup with App Engine by creating at least two separate projects, one project for testing and another project for production. It's important to create separate projects and not just separate services within the same project, because different services within a project can actually share the same data within Google Cloud services. For example, Firestore and Cloud Storage both share the same data to different App Engine services within the same project. This opens up the chance for testing and production code to cross-contaminate their data, which is not good. The best practice is to create a strict separation between environments, and creating separate projects is the best way to ensure the separation. So let's go ahead and check out the separate projects I've just created. Let's take a look at the production project and notice the format of the versions. The version names are in the format of a timestamp and a git hash. We have a timestamp to easily determine the order of deployments. And we use a git commit hash so we know exactly which git commit has been deployed to this version. This allows us to easily roll back to a specific point in the commit history. For example, if we want to roll back to a specific commit, we just look for the matching commit hash in the versions and roll back to that. Next, we also have this feature X version over here. This is useful for testing or gradually rolling out versions that contain a specific feature that we want to test in production with real users. Ideally, we can use traffic splitting to control and manage the impact of testing this version. Next, let's check out our test project and see the versions it has. First, we have a matching git hash and timestamp with the latest version in production. It's useful to maintain that the default version in the test environment is also the default version in the production environment. This guarantees that we can test the latest production code in the test environment by just going to the default test URL as well. Next, we have these feature X, feature Y, feature Z versions over here. These are features that can be tested and verified by the QA team separately and in parallel. For example, we can deploy a feature X branch to its own version in the test project and hand it over to our QA team. Then deploy another feature Y branch to its own version as well, so it can be tested independently and in parallel to the other features being tested. Now let's take a look at how this looks like in the Cloud console. Here, I have two browser windows that I've opened side by side. One is for a test project, and the other is for a production project. Each version here in the test project have their own URL, which we can use for testing these features independently. This is really useful for the QA team. Now in the production project side, we have our versions organized into timestamped and git commit deployments. This is useful for performing migrations and rollbacks if necessary. Notice the feature X version over here. We can split some of the traffic to this version in order to test this feature. This is useful for testing feature changes with a smaller set of users before rolling it out to everyone. This is one of the ways we can use component-specific URLs in App Engine and multiple projects in order to create separate test and production environments. that make it really easy for developers, testers, product owners, and users. Now, an ideal next step would be to integrate this with our CI/CD pipeline in order to automate this workflow and make life easier for the developers. Sometimes, when you deploy a new version of your application, you might want to roll it out to a small subset of your users initially, in case something goes wrong. Or, you might want to test it first with a subset of users to see if it gets a positive response. You can do this with App Engine traffic splitting. In traffic splitting, we can set that incoming traffic requests get routed to different versions of our application. First, we go to the App Engine versions page. You can see all the different versions that we have deployed in our app. For now, we can see that all traffic is being served through only one version of the app. Now we can split some of the incoming traffic to the other versions of the app. To do this, we press the split traffic option over here. Now we have three options on how we can split traffic. The first one is by IP address. This means that the traffic will be routed depending on the IP address of the request. This is recommended when your users don't use cookies by default, like apps or non-browser-based HTTP clients. The second one is by cookie. This option is easier to implement for browser-based apps, as cookies are already set up by default, though we would have to add a cookie ourselves to make this work. The third one is random, which basically just routes requests to a random version depending on the percentage that version is set to receive. This one, however, will mean that the user doing multiple requests could hit a different version at different times, even within the same session. Let's try random. Let's select it. Now, we can add as many versions as we want, but let's just stick with 2. Now, we set how much traffic we want the split to be. Let's go with 50-50. And press save. Let's press back over here. And as you can see, our traffic allocation is now set to 50% for version 1, which is the background color deep sky blue, and version background color pale red, 50% as well. Let's try it out and see if it works. Let's visit our site, and as you can see, it has the red background version. Press refresh, still the red one, refresh again, and now we got the blue. Refresh, refresh back to red, and we keep pressing refresh, and we get 50% approximately of the time randomly, the red and the blue. Now I think the blue version is better. So let's go back and migrate 100% of our traffic to the blue version. So let's select the background color deep sky blue version and press migrate traffic. Yes, migrate. Now all traffic should be routed to the blue version of our app. Let's check and see. Let's hit refresh, 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 and let's keep refreshing, and it's blue all the way. Alright, now you know how to perform traffic splits, migrations, and using the same principle, you can do rollbacks to previous versions of your application if necessary. And that's all there is to it. It takes a lot of effort to properly maintain and tune a database. Cloud SQL is a fully managed database service for MySQL, Postgres, and SQL Server. Cloud SQL takes care of uptime, replication, backups, and scaling. Let's create our first database instance by clicking on Create Instance. Cloud SQL will give us 3 options for our database engines. Let's pick MySQL. To create a MySQL instance, we'll have to fill up this form. You can set the instance ID to anything you want. For this one, let's use my pet project database. Next, the root password is the password for the root user of our database. We can set it to no password, or we can press the generate button to create a unique and secure password for us. Let's copy paste this for our reference later. Here, we pick the region and the zone, which is basically the location of where our database instance will run. Ideally, keep it in the same location as the services that will access our database. So for example, if some of our VMs in Compute Engine will access our database, and their location is in US West 2 Los Angeles, then we should also set the location of our database to the same region. The region is permanent, but the zone can be changed at any time. We can pick the zone or just set it to any. We'll leave ours as any. We can also pick the database version. Let's just go with the latest one. Now there are a lot of other configuration options which we can see if we click Show Configuration Options over here. Let's start with connectivity. We can pick between private and public IP. The main difference is private IP is only accessible inside or through your virtual private cloud, while public IP is accessible from anywhere. However, with public IP, we have two options for connecting to it. We can connect to it via the Cloud SQL proxy or by whitelisting a set of public IP addresses. We can specify a single IP or a network range. Let's add my IP address. What is my IP? There you go. Let's add that and let's whitelist that. Now for machine type and storage, this is where we choose how big and powerful our database will be. And right below it is the network throughput. The network throughput of our database is also related to our instance size, which means the bigger our instance, the higher its network throughput. Let's change it. As you can see, there are many options, from as small as 1 CPU and barely a gig of RAM to as big as 96 CPUs with over 600 gigs of RAM. Each one has a different price, so choose the best one for your needs. And as you can see here, clicking on any of the bigger instance sizes also increases the network throughput, since they are connected. For storage type, we can choose between SSD or HDD. We'll pick SSD since it's the high performance option. Storage capacity picks the initial storage size of the database instance. If we check Enable Automatic Storage Increases, then when our database grows and approaches the limit we set, then it automatically increases the storage size without us having to manually resize the database. Now look at the disk throughput over here. If we increase the storage size or the storage capacity, then the disk throughput also increases. These numbers are related to each other, so that the higher storage capacities will allow for higher disk throughputs. Let's stick with 100 gigabytes. Now let's talk about backups. We can enable automatic backups and the time when they happen. We can also enable point-in-time recovery, which allows us to recover a database to a specific point in time. And we can also choose between single zone or high availability. High availability keeps a replica of our database in another zone, so that if the main database fails, then it automatically fails over to the replica. This is recommended for production deployments. We can also set specific database flags if necessary under this section. We just need to select the flag name and its value, and that's it. The maintenance section allows us to set the preferred maintenance window, setting the day and the time, and whether this database instance will receive the maintenance event earlier or later amongst all our other database instances. We can also add labels to our instances to help us group and organize our instances. For example, we can set our environment label to test or production, whichever this instance is for. And finally, we just press create and wait as Cloud SQL creates our database. This usually takes a few minutes to complete. Great! Our database is now created. We now have a fully managed database running in Cloud SQL. Alright, now we're going to understand how to create and manage service accounts. Service accounts are similar to a user account, except that it's designed to be used by an application or service. We can view all our service accounts by going to the Google Cloud Console, going to the I am an admin tab, and pressing Service Accounts. There are two types of service accounts, the ones we create ourselves and the ones automatically created by Google services for us. There are no differences between the two, just on how they were created. These accounts over here were created by Google automatically. This one, My Pet Project 285907 at appspot.gserviceaccount.com, is also known as the default App Engine service account. This is the service account that our Google App Engine application uses. So if we want to grant our App Engine application more roles and access to other cloud services, like Cloud SQL for example, we can add permissions to this service account. Actually, let's try that out. Let's try adding a Cloud SQL client role to our App Engine service account. To do that, let's go to the I am page over here, and let's look for our service account. And there it is. We can press Edit and add another role. Enter Cloud SQL Client, and then let's press Save. That's how you add a role to a service account. We can also remove roles using the same process. Now there are other accounts, service accounts automatically created by Google Services over here. Now we're going to try creating our own service account. Let's go back to the Service Accounts tab and press Create Service Account button at the top of the page. We have to provide three things: a name, a unique ID, and a description for our service account. Let's type the name that we want. It's generally a good idea to give it a name that's relevant to which service is going to be using this account. Let's pretend we're going to use this service account for our main application. So let's give it the name Main Application. Now, as you can see, the ID is automatically generated for us, but we can also customize it. Let's say 1, 2, 3. And for the description, let's put something here that will help us remember what this is for. So Access Cloud SQL. Let's press Create. Next, we can enter account permissions. This step is optional, but if we don't add permissions to this service account, it won't be able to do anything. It's basically useless. So let's go ahead and add the Cloud SQL role that we wanted to add. Cloud SQL. We can add as many roles as we want, but for now, let's just stick to Cloud SQL and press Continue. Next, we can grant users access to this service account. For now, we will skip this step and press Done. Now we can see our newly created service account in the list. To manage our service account, we can click our service account and have multiple options. We can add a new key to our service account and create a new one by pressing the Add Key and Create New Key button. Then select JSON and press Create. This automatically downloads the key to our computer, which we need to store securely. This key will be able to access the Google Cloud services that this service account has access to, so treat this as a secret. Next, we also have the option of disabling or deleting our service account. Now, disabling is temporary, but deletion, it's permanent. All right, that's how we create and manage service accounts in our Google Cloud project. We now have a database in Cloud SQL. It's time to connect to it from our App Engine application. Let's learn how to do that. First, let's select the database instance we want to connect to. Then we see this Connect to this instance section over here. We have many options. For example, connect using Cloud Shell, connect from a Compute Engine VM instance, and we have the option to see all connection methods. Since we're going to connect from Google App Engine, let's go to see all connection methods. Let's press Connecting from App Engine. Alright, we've landed on Connecting from App Engine Standard Environment to Cloud SQL. There are options for different databases over here, but we're going to follow the MySQL option since our database is MySQL. So the first step is to set up a Cloud SQL instance, but since we've already done that, then we'll skip this step and head straight to configuring App Engine. There are two options to connect. Either we use the public IP or a private IP. The default is public IP, and this is what we're using. The first two instructions are to verify that we have a public IP address and an instance connection name. So let's head over to the Cloud SQL Instance Overview page and see our public IP address over here and our instance connection name over here. The third step is to ensure that our App Engine application service account has the right permissions to access Cloud SQL, and has to be either one of these: Cloud SQL Client, Cloud SQL Editor, or Cloud SQL Admin. Let's head over to the IAM page and look for the service account of our App Engine application. It's over here. Notice how it says App Engine Default Service Account. Let's click on Edit to pull up Edit Permissions and add another role. Let's enter Cloud SQL Client and press Save. Alright, we've finished the configuration settings for App Engine. We have our Node.js application here. So we're going to copy-paste this snippet from Node.js. This code snippet uses the MySQL library to connect to our database in Cloud SQL. We've added the snippet in lines 6 to 19. As you can see, it's using environment variables here. So let's go to our app.yaml file and configure the necessary variables. We've added Cloud SQL connection name, which we got from the Cloud SQL overview page, DB user, which is our username root, DB pass, which is the password of our root user, and DB name, which is the name of our DB. Back to our app, we've created a simple query in line 25 to test the connection to our database. And in line 35, we say connection to database successful if there are no issues. Now let's deploy our App Engine application by running gcloud app deploy app.yaml. Let's hit enter. While we're waiting for our app to be deployed, it's important to understand that since our app is using a service account to connect, then it will only be able to connect if it's running in the cloud on Google App Engine. This is because the default service account is tied to the online servers running our App Engine application. For testing locally, it's recommended that we use a local MySQL instance and connect to that locally. And now our app is deployed. Let's refresh it and verify that it's connected to Cloud SQL. And connection to database successful. Now when deploying App Engine to Cloud SQL in a deployed environment in the cloud, App Engine is going to use its own service account to authenticate with Cloud SQL. This is very good for security and is actually quite convenient. However, when connecting locally, this won't work, and we have to use a different approach. We're going to learn how to use the Cloud SQL proxy to connect our local development environment to a Cloud SQL instance in the cloud. What Cloud SQL proxy does is that it gives us a way to connect to our Cloud SQL instance from our local development environment, as long as we have a valid service account. This mimics the behavior of our deployed App Engine application service. It handles the service account authentication for us, so we can just focus on the connection and making the queries. Now we are on the documentation page for this. Let's focus on installing and using Cloud SQL Proxy for local testing. Before we begin, let's complete the following tasks. We already have a Google Cloud project and a Cloud SQL instance. Next, we ensure that our Google account has permissions for Cloud SQL. It has to be higher than the Cloud SQL viewer role. In this case, the owner role has a higher level of permission and is enough to access Cloud SQL. Finally, we've already installed the MySQL client as well. Next, let's enable the Cloud SQL Admin API for this project. Let's click this button over here, which will take us to the Enable API page. Alternatively, we can also enable APIs by simply typing the name of the API in the search bar. Let's type Cloud SQL Admin API and select what comes up. As you can see, we're brought to this page where we can enable it. So let's enable it. Let's select the project we want to enable it for, and it should enable it for us. If you have not installed or set up gcloud yet, you can follow the instructions over here. In our case, since we've already set up gcloud, then we just need to verify that we are logged in with our Google account in gcloud. Now let's download the appropriate binary for Cloud SQL Proxy Client. As you can see here, there are many different options for different operating systems. In my case, I'm going to go with Mac OS 64-bit, which is what I have. Now let's copy-paste the download command to terminal. And once that's done, let's also make it executable. Alright, time to start the proxy. This is the command, but let's replace the instance with our connection name and set the port to TCP 3306, which is the MySQL port. And that's it. Our Cloud SQL proxy client is now listening for connections. Let's test it by connecting to it from our App Engine application locally. First, we create another function in line 23 for connecting via TCP to our local MySQL service, which is actually the Cloud SQL proxy. Instead of the instance connection name, it uses the DB host environment variable along with the port in line 25. It's important to note that the environment variables defined in app.yaml are not available to the application when run locally. That's why we also have to define our environment variables separately for our local testing. In this case, we have a .env file to define our environment variables. In line 7, we've added a DB host pointing to localhost 3306, which is what Cloud SQL proxy is listening to. And let's run it. npm run start. And there we have it. We've now connected our local development environment to our Cloud SQL instance in the cloud. When deployed, this will also automatically switch over to using the App Engine service account and connect from there. Now, as a best practice, it's recommended that we use different databases for our production and development environments. With GCS, everything is stored in something called a bucket. You can think of this like a hard drive in the cloud where you store all your files. And in GCS, these files are called objects, buckets, and objects. Let's begin and click Create Bucket. First things first, we have to name our bucket. It has to be a globally unique name. It will be part of the object URL, so it has to be globally unique. We'll try my pet project bucket and press continue. Now before we continue, I want to draw your attention to the right-hand section here where it shows monthly cost estimate. Let's fill this up to see how much we will end up spending given our different bucket settings and configuration. Let's add some imaginary values here for our bucket, which we will use to store videos to the tune of 10 terabytes or 10,000 gigabytes and a monthly retrieval or download size of, let's say, 1,000 terabytes or a billion gigabytes. Now for operations, there are two types of operations. There's the Class A operations, which are write operations, like creating a bucket, uploading files, setting permissions, and deleting objects. Now Class B operations are read operations, like downloading objects, viewing object metadata, and retrieving permissions. Let's set our Class A operations to 10,000 operations, since we'll be uploading about 10,000 videos to our bucket. But let's set 100 million Class B operations, since each video will be downloaded many times. Now, we have an estimate of our monthly cost as well as the availability SLA for our bucket. Let's watch this number also change as we change the bucket settings and configuration. Okay, now let's choose the location where our data is stored. We have three choices: region, dual region, and multi-region. Region is the cheapest and is only stored in a single region. Dual region is the most expensive and offers high availability and low latency across two specific regions. And multi-region offers the highest availability across a large area. Now for multi-region, we can choose between Americas, Europe, and Asia Pacific. It's best to choose a multi-region closest to where most of your users will be accessing the data from. Let's pick Americas and press continue. Next, we can choose a default storage class for our bucket. Standard is best for short-term frequently accessed data, while archived is best for long-term infrequently accessed data. And nearline and cold line are sort of like the middle ground choices in between standard and archive. Now, if we select archive, you'll notice the price will go up dramatically. This is initially surprising because archive is supposed to be the cheapest option. It is the cheapest option for monthly storage cost in terms of storage size. However, retrieval costs for archive is the most expensive. The opposite is also true. Storage costs for standard are the most expensive compared to all the other classes, but retrieval rates are the cheapest. Now let's remove the retrieval data and pretend that we are only going to store our videos as backups and nobody's going to access them anytime soon. As you can see, archive is now the cheapest option, followed by cold line, nearline, then standard. And standard is now the most expensive option. Let's press continue. Now we set access control permissions to the objects in our buckets. We have two choices, fine-grained and uniform. Fine-grained lets us set the permission at the per object level, which means that each object in the bucket can have different permissions. For example, one object can be private and another object in the same bucket can be public. Uniform, on the other hand, sets the permission definition at the bucket level, such that all objects will have the same permissions. Let's continue to the final but optional setting. For encryption, we can choose between Google Managed Key and Customer Managed Key. This refers to the encryption keys that encrypt our data when GCS receives and stores it. We can let Google manage the encryption keys automatically for us, or we can manage it ourselves and supply Google with encryption keys. We can also set a retention policy that forces retention and disables deletions for a specific period of time. For example, if we are storing medical record data and government regulations dictate we should store our data for at least 5 years, then we can set it here to prevent accidental deletions for at least 5 years from when an object is uploaded. Another option is to add labels in order to help us group this bucket with other cloud resources we use in our account. Now, let's press create and create our bucket. Now, our new Google Cloud Storage bucket has been created and it's now ready for use. Let's learn how to upload files to Google Cloud Storage. Before we go on, let's familiarize ourselves with the common terms for GCS. The first term is buckets. I like to think of buckets as the main hard drive. You put all your files in it. The only difference between a GCS bucket and a hard drive is that a GCS bucket has virtually unlimited storage size. The next term is objects. An object is a single file. Objects are what you save in a bucket. Now, there are many ways of uploading files to GCS. You can do it through the console, through the gsutil command line tool, through code, or through REST APIs. Let's try with the Cloud Console first. Pressing this button takes us to the Google Cloud Console inside the storage browser where we can see the list of buckets that we have. These are all buckets. Let's select one of the buckets, say my pet project bucket. To upload a file, let's click this button that says Upload Files. Let's select the file that we want to upload. There, we've uploaded it to GCS. If you're using Google Chrome like I am, you can also upload an entire folder at a time by clicking this Upload Folder button. To download an object, we just click on the 3 dots over here on the right side and press Download. This will download the object that we've selected. Now let's try uploading using the gsutil command line tool. Let's open up our terminal and notice that we have 3 files in our desktop folder. Assuming you've already installed the Google Cloud SDK, type gsutil -cp, also known as copy, and enter the file. In this case, let's upload sunflower2.jpg and the destination bucket. In this case, my pet project bucket. Let's press enter. And there it says operation completed over 1 object. Let's go ahead and check it. Let's hit refresh. And there it is. To download an object using gsutil is the same command. We just reverse the source and destination. So we enter gsutil cp, and then we put the GCS object we want to download, gs:// my pet project bucket / sunflower2.jpg space. We specify a local path. In this case, we want, say, downloaded sunflower.jpg, and we press enter. And there we have the file. Let's try it out. Open downloaded sunflower.jpg. And yes, there's our photo. There are other ways to upload GCS using code. Here are some examples that you can use with the programming language that you want. Each programming language over here has a corresponding GCS client library that you can use to easily interact programmatically with GCS. There are some samples over here that are ready to copy and paste. Finally, if you want to get down all the way to the most basic API level, there's also JSON and XML APIs that you could use to interact with GCS. And that's it. That's how you upload and download files to and from Google Cloud Storage. Permissions for Google Cloud Storage. There are two main ways to secure our Google Cloud Storage buckets. First, the uniform setting. This configures the permission setting on our entire bucket, and all the objects in that bucket inherit that permission. And second, there's the fine-grained setting, in which GCS lets us set the permission settings for each individual object in our bucket. So basically, each object in the bucket can have different and unique permissions from each other. This is a more risky setting security-wise, as we have to pay extra attention to the individual objects and make sure they have permissions set properly. However, there are certain use cases where this can definitely come in handy. As much as possible, try to go with the uniform setting first. Anyway, let's learn how to configure these settings. We start by going to the Google Cloud Console and into the storage browser. We then select the bucket that we want to configure, in this case, my pet project bucket. Then we go into the permissions tab over here. This is the page where we can set the default permissions of the bucket using IAM policies. Our current bucket has been set to uniform permission settings by default. Let's change it to fine-grained by clicking the Switch to Fine-Grained button over here. And then we change the setting to fine-grained. Now there's a warning here that pops up saying that this will basically restore any previously set object ACLs, which may grant wider object access than our bucket's IAM policy. In other words, if we have any objects that have less restrictive permissions, like being set to public access for example, then setting our bucket to fine-grained will allow that object to be publicly accessible even if our IAM policies in this page are set to private. This is because the fine-grained setting allows objects to have their own permission settings. So, yep, we know what we're doing. Let's press save. Now let's go back to our list of objects. And let's try to set permissions for each object individually. We go over here, we press the three dots, and we see this edit permissions option over here. And let's try to make our object public. Let's press save. And ta-da! Our object is now public to the internet. Now there are ways to set these permissions programmatically and through code. But for this video, we'll just edit them here through the console. Now let's go back and try to set our bucket permissions back to uniform. Switch to uniform, and let's save that. Let's go back to objects and notice two things. First, our object is now back to being private, and all the objects have uniform permissions. And second, if we click the three dots, the option to edit permissions is now gone. All permissions for this bucket will now be managed using this permissions tab over here. If we want to make all the objects in our bucket public, we just press add. We add all users, and then for the role, and we add storage object viewer to the role, press save, and allow public access. Press update, and let's see. And ta-da! All our objects are now public to the internet. And now we want to make them private again. We just remove the public permissions. And they're all back to being private. Alright, once again, those are the two ways to secure your buckets and objects. When in doubt, just remember that the uniform setting is the recommended one and tends to have lesser prices than the fine-grained one. We're going to learn how to create signed URLs for Google Cloud Storage objects. Signed URLs grant temporary access to any user who uses the URL to private objects in GCS. The way this works is our app uses a service account that has access to our private GCS object. One use case is that a user makes a request to our app. Our app then wants to give the user access to a specific private object in GCS. The app uses the service account and generates a signed URL for that private object and returns that to the user. The user then uses that signed URL to access the private object. GCS recognizes the signature and returns the private file to the user directly from GCS. Now there are multiple options for generating a signed URL. For this video, we will explain the v4 signing method. This is how a signed URL looks like. It starts with a path to our GCS object, and then it has all these additional query parameters added to it. Let's break this down into parts and go through it one by one. This one indicates the signing algorithm. This one describes the credentials, and this one is the start date of when the URL can be accessed. We can also set this to the future. This one is how many seconds from the start date the URL will remain valid. It can be up to 7 days. Then the signed headers, and then the most important part, the signature. This is the string that proves that this request has been authenticated, and this is what the GCS service will use to check if this is an authentic signed URL. Alright, now let's go over the algorithm for generating a signed URL manually. First, we need to have the credentials from a service account that has access to our private GCS object. And it needs to have at least a storage.objects that get permission. As you can see, we've made one over here, and we can use a storage object viewer role for this. Say we want to grant access to this husky photo over here. Oh, it's a cute one. Right now, as you can see, it does not have a public URL. And also, it's not accessible directly through its normal URL. So let's try to create a signed URL for this. Doing this manually is possible. However, it's quite a lengthy process and it's easy to make mistakes. The easier way is to just use the libraries already provided for us. Let's take a look at those options. The first option is to use GSUtil. GSUtil is installed together with the gCloud SDK. To use it, we need to create a private key for our service account. We already have a service account and we've also downloaded its private key locally. Now we just have to follow this GSUtil command and replace it with our details. GSUtil sign URL -d 10 minutes GCS viewer service account pk.json and gs://mypetproject_bucket, which is our bucket name, /husky.jpg, which is our file. It's returned a signed URL. Let's copy and paste that to our browser. And ta-da! We now have access to the private husky photo. Let's also try another method using Node.js. Let's copy and paste this code sample to our signURL.js file. At the top of the file, let's read this to-do comment over here. It's asking us to uncomment the following lines and enter our bucket name and file name. Our bucket name is mypetprojectbucket and our file is husky.jpg. Let's enter those. Now in line 10, since we're using the Google Cloud Storage library, let's also run npm install at Google Cloud Storage to install that library. Then, let's read that note again in line 3. It says, unless running in a GCP environment, a service account must be used for authorization. Since we're running this locally, we are not in a GCP environment. So let's specify the service account private key file to use. We can do that by adding key file name GCS viewer service account pk.json to our storage object in line 13. In lines 19 to 22, we are also passing additional options. Like this will generate a signed URL using the version 4 signing method, and for the action we're using read, and expires in 15 minutes. I think we're good to go. Let's run it. Node signurl.js. And we have the signed URL. Let's copy paste it to our browser. And we have the same photo again. Great! We can now access the private object in GCS using the signed URL. There's actually another snippet over here. This one is for generating a signed upload URL for the user. It's basically the same code, but instead of a read action, it's a write action. This is for generating a signed upload URL that the user can use to upload a file into a private GCS bucket. There are already libraries for most common programming languages. You can see a couple of samples over here, like C++, C#, Go, Java, and others. And that's it. You're now ready to generate signed URLs for your own application. Object Lifecycle Management allows us to automatically manage the lifecycle of an object when specific conditions are met. Like if it reaches a certain age, we can have it automatically downgraded to a cheaper storage class or deleted so we can save on costs. This allows us to have a lifetime or time to live on objects saved in our bucket. Let's imagine that we have an online file download service. Our users upload a file to our service and then we give them a download link to share to their friends. With this kind of service, we notice that most of the files are downloaded within the first 30 days and are usually no longer accessed after that. In addition, we want our download links to expire after 1 year. Let's use Object Lifecycle Management for that. To set lifecycle management rules, we go to our bucket in the Google Cloud Console storage browser and go to the Lifecycle tab. It's important to note that lifecycle rules apply to all objects in a bucket, and that an object's age is counted from the time it is added to this bucket. And if an object meets the criteria for multiple rules, then the lowest level action will take effect. For example, deletions will always win over a downgrade to another storage class, and a downgrade to the lowest class will win over a downgrade to a lower class. To add our first rule, let's press this Add a Rule button. Now there's two things to set when adding a rule. First, we have to select an action. And then, we then select the object conditions that need to be met. For our first use case, we want to downgrade our object to archive. So let's select Set Storage Class to Archive and press Continue. Now we have to set all the conditions that have to be met when the action will be triggered. These are the types of conditions that we can set. Age, which measures the days elapsed since an object has been uploaded or added to the bucket. Creation date, which you can set to include all objects created on or before a specific date. This is useful for downgrading or deleting all objects created before a specific date. Storage class is for selecting objects in specific storage classes. This is good for further downgrading objects or finally deleting them. Newer versions and live state used together allow us to delete older versions of objects once they reach a specific number of versions. This allows us to support versioning of objects while downgrading or deleting older versions when there are already many newer versions ahead of it. Let's go with age. Set it to 30 days, and let's also set the storage class to standard. Let's press continue and then create. Yay! We've added our first rule. Now let's add our next rule for expiring objects after a year. Let's press add a rule again. This time, we want to set the action to delete. Let's press continue and let's set the age to 365 days. Let's press continue and create. Now we have two rules that allow us to downgrade our storage class after 30 days and expire our links and delete them from our bucket after 1 year. This is all done automatically through Google Cloud Storage Object Lifecycle Management. Cloud Tasks lets us create tasks and execute them in the background. There are two types of tasks: App Engine tasks and HTTP target tasks. App Engine tasks target endpoints within an App Engine application. HTTP target tasks can target any publicly available URL. The two main components of Cloud Tasks are tasks and queues. Tasks are basically HTTP requests that will be executed in the background. Each task contains a task name, which is automatically generated for us if we don't define it, a target post URL, and a payload, which is what Cloud Tasks will send the request to, an execution schedule in the future if we want to define it. Otherwise, Cloud Tasks will try to execute it as soon as possible depending on the configuration. And finally, a queue to place the task in. Now, queues are where tasks go into, and queues manage the execution of those tasks. Queues control the rate of execution of tasks per second. It also controls the maximum concurrent number of tasks executing in parallel, burstable rates using token buckets, and retry and backoff configurations when errors occur. There are multiple ways to create a queue. We can create it through gcloud, Cloud Tasks API, or through queue.yaml. In this video, we will use the gcloud method. Let's go ahead and try to create a queue and some tasks. Let's go to terminal and enter gcloud tasks queues create test queue. And let's describe it. As you can see here, we have rate limits, which are max burst size, max concurrent dispatches, and max dispatches per second. Now, max concurrent dispatches is greater than dispatches per second because even though we are dispatching 500 per second, if task executions take longer than a second to complete, then the number of concurrent tasks executing will go over 500 very quickly. Max concurrent dispatches keeps a cap on this in order to not overwhelm the task endpoints processing the tasks. For the retry config, this is useful when the task endpoints time out or return errors. When an error occurs, Cloud Tasks will retry based on this configuration. Max attempts will be the maximum number of times a task will be retried. Min backoff is set here for 100 milliseconds, which means the first time a task returns an error, Cloud Tasks will wait for at least 100 milliseconds before retrying. Then if it still fails, it will double that waiting time before trying again. It will keep on doubling that waiting or backoff time up to 16 times, in this case, up to a maximum of 3,600 seconds, or 1 hour basically, until it's retried it for a maximum of 100 attempts. And lastly, we can see the state of our queue, it's running. This is how our queue looks like in the Cloud Tasks console. Now let's try creating some tasks. I have an App Engine Node.js code here that creates a task in this create task endpoint in line 73. In line 74, it creates a task for test queue and sends a payload of hello to the /task endpoint, which we've defined in line 82. Let's trigger that create task endpoint in the browser. and our task is created. We can see here that one task has been executed in the past minute. This was the task that we just created. Let's go ahead and open the queue. As you can see, we have no tasks in this queue. Now we have the option to pause our queue. When a queue is paused, all new tasks added to it will not execute. Let's add a few more tasks by refreshing our endpoint a couple of times. Let's refresh our queue. And as you can see here, we have a couple more tasks added to the queue. But since it's paused, they are not yet being executed. We can manually trigger a task to run now by clicking this button. We can also delete some tasks by checking it and pressing delete. Deleting a task removes them from the queue without executing it. We can also purge queue, which will delete all the tasks in the queue, which we don't want to do right now. Let's go ahead and resume this queue and refresh it. And now, all our tasks have been executed. And that's how we create queues and tasks in Cloud Tasks. Alright, now we're going to learn how to send a lot of emails to our users using App Engine and Cloud Tasks using the fan-out pattern. Before we can create tasks, we need to do two things first. First, we need to enable the Cloud Tasks API. Let's do that by going to the Cloud Tasks API, then pressing Enable. Next, we need to create two queues. We can do that by going to the terminal and using gcloud. The commands are gcloud tasks queues create email task generator, which is the name of our first queue, and gcloud tasks queues create email sender, which is the name of our second queue. Let's verify that our queues have been created by going back to the Cloud Tasks page, and we can see our queues over here. Next, let's look at our code. I am using Node.js, but this is implementable in other programming languages as well. I'm not going to focus on syntax, but rather on the concept of how to implement the Cloud Tasks pattern. In line 22, we have a create task function that helps us create a task. It accepts the name of the queue, a payload, the path endpoint to trigger, and a delay in seconds of task execution. Now, before we jump into this further, let's first review how we would send emails without Cloud Tasks. In lines 81 to 94, we have the send emails normally endpoint. In line 83, it takes the emails from the database. And then on line 86 and 87, we loop through all the emails, sending an email for each email address. This is a very simple way of doing it, and it will work if the number of emails we're sending is small. However, this will become problematic once we have thousands or hundreds of thousands of emails to send to. Then this loop will take very long and it might even time out and won't be able to complete the loop. Now this is where tasks become useful, because we can then put the actual sending of the email process in a background task and do it in parallel. In lines 96 to 110, we have the create send email tasks endpoint. It's very similar to our previous function, except that in our loop in line 101, we create a task instead of sending the actual email. This basically adds it to our send email queue. The create task function takes in the name of the queue, in this case, our variable sender task queue name. Then we also pass the payload, containing the email, subject, and email body. And lastly, the endpoint path, which the task will use to execute, which is the send email endpoint. What happens here is that instead of sending the actual email, a task is created which then takes the email, subject, and email body and passes it via a POST request to this send-email endpoint in line 112, which then takes care of sending the actual email. Now, if you have hundreds of thousands of emails, this for loop in line 101 for creating tasks is still going to loop 100,000 times and is still at risk of a timeout. So this is where the fan-out pattern comes in. In a common task pattern, our code creates tasks, which then sends emails. Now in a fan-out pattern, instead of creating tasks directly, we create tasks that create tasks and then sends emails. It looks like this in code. In line 126, we define our fan-out endpoint. In line 128, we get the total count of emails so we know how many we need to send to. Then in line 131, we decide on a batch number, and this is the number of tasks each of our task creators will create. Let's set this to 100. So for 100,000 emails, our main task generator will basically have to create 1,000 task creators. The first task will have a start count of 0 and a batch size of 100. The next task will have a start count of 100 and a batch size of 100 as well, and so on until we reach 100,000. In line 148, let's take a look at our generate send email tasks endpoint. In line 149 and 150, we retrieve the start count and batch size and use that to set our query parameters, which we execute in line 153. We retrieve the email addresses from the database, then create a task for each in line 158. This fan-out pattern is able to perform more tasks in parallel than just a normal task creation pattern. So our application has actually been deployed in App Engine, so we can see it in action. Let's hit our fan-out endpoint using curl to trigger it. Let's check out the Cloud Tasks page, and we can see our queues filling up quickly. Let's keep refreshing. Here we can see our email task generator queue and our email sender queue. I also want to show you that our App Engine instance count has also automatically scaled up to fulfill the increased demand to execute the tasks as they are being created and executed. That's it. That's the fan-out pattern using Cloud Tasks. Google Cloud Scheduler is a fully managed cron job scheduling service for the cloud. It's basically the cron jobs for the cloud. It lets you configure triggers to create requests to specific HTTPS endpoints or send messages to pub subtopics at a given schedule. This is useful, for example, for sending summary emails to your users every day at 7 a.m. or for deactivating users every midnight if they haven't logged in for more than a month, or running a backup script every Sunday midnight. Let's create our first job by pressing this button. It takes us to this form to configure the details of the scheduled job that we're making. First, we give it a name. It has to be a unique name to this project. And then give it a description. Next, we configure the frequency. Now this frequency uses the Unix cron format. Let's take a look at it by clicking on Learn More. So basically, it's a set of 5 values, each separated by a space, which defines the schedule. It's the minute, then the hour, then the day of the month, then the month of the year, then the day of the week. For our case, we want it to run daily at 8 a.m. UTC time. So that's on the 0 minute of the 8th hour of every day of the month, of every month of the year, of every day of the week. And let's set the time zone to UTC, which is essentially the same as GMT. Now just a side note, this configuration is good when our users are all in the same time zone. But what if we have users all over the world in different time zones, and we want them to receive the email at 8 a.m. in their time zone? Then in that case, we can set a job to run every hour and then we handle the filtering of which users should be sent an email in our endpoint instead. Another caveat to note is that Google Cloud Scheduler uses the wall clock time of the time zone. So if we use a time zone that has daylight savings time changes, then our cron job will also adjust the schedule during the time changes. This could mean that some jobs can be triggered twice during a switch back or skipped during a switch forward in daylight savings time. To avoid this issue, it's best to just stick to UTC, which doesn't have daylight savings time. Finally, we pick the target. We have three options: HTTP, which can be any public URL; PubSub, which can be a PubSub topic that we have access to; and App Engine HTTP, which is an App Engine application in this current project. If you want to target an App Engine application in another project, use HTTP instead. We'll go with HTTP. We can enter the URL, including the path that we want to trigger. Then select the HTTP method. In this case, we'll go with post. Then we can optionally add in the data for the body. In this case, we'll leave it empty. If we selected PubSub, then we would set the topic and the payload. If we want App Engine HTTP, then we just have to specify the relative path, along with some options to set the service, method, version, and instance. Now let's go back to HTTP. And let's create our job. And that's it. Our job will now be running on the 0 minute of every hour EC time. Alright, now we're going to use Google Cloud Scheduler to trigger a task that sends emails to our users every day. In line 94, we have a Generate Morning Email Tasks endpoint, which we want to trigger every 8 a.m. on the user's time. The challenge is that the users are in different time zones. To solve this, we plan to trigger this every hour, and then filter the users according to who should get the 8 a.m. email at that time based on their time zone. So line 96 only retrieves the user emails that are 8 a.m. at their time zone, and then creates the tasks to send them emails on line 99 onwards. So what's left to do is to simply trigger this endpoint every hour on every day. And that's what we're going to use Cloud Scheduler for. Let's open the Cloud Scheduler page in Google Cloud Console and create a new job. Let's give it a name: Send Daily Emails. Let's give it a description. For the frequency, let's set it to trigger every hour, which is on the 0 minute of every hour of every day of the month of every month of every day of the week. For time zone, let's pick UTC as a best practice. For our target, let's pick App Engine HTTP. And let's also set our URL endpoint, which is Generate Morning Email Tasks. Let's leave the service blank so it uses the default service. Let's use HTTP post method, which is the method our endpoint uses. And let's leave version and instance as blank so it uses the current active version and any active instance in our App Engine app. Let's also leave the body blank, as our endpoint does not really need any input in order to work. And let's press create and see our job getting created. Now our job is created. Let's test it by manually running it. The result is success. We can also see that it's triggered the task creation for sending emails as well. Now this will trigger every hour on the hour based on our schedule from now on. And that's it. That's how we create a job that triggers an endpoint with an hourly schedule. Cloud logging is where we would send all our logs from all our systems and applications in order to make it easy for us to view the overall health of our systems. There are many ways to write logs into the logging service. Let's go over all of them. If you use any of these services like App Engine, GKE, Cloud Run, and Cloud Functions, they are already collecting and sending logs to Cloud Logging out of the box. So you're all set, and additional setup is optional. Now, if you are using Google Compute Engine or AWS EC2, you can use the logging agent to collect and send logs to Cloud Logging. There are instructions on how to install and configure the logging agent in Google Cloud's documentation. If your application is running elsewhere, then another option is to use any of the logging libraries to send application logs to Cloud Logging. There are libraries for many of the popular programming languages available. If you'd like, you can also call the Logging API REST endpoint directly. And of course, you can also send logs using the Google Cloud SDK G-Cloud command line tool. Actually, let's try that one out. Let's go to our terminal and use G-Cloud and type G-Cloud logging write pet project log, a simple entry. Let's press enter. And yay! We've created a log entry. That's how we write a simple log entry. Let's now try making a structured log entry. G-Cloud logging write payload type equals JSON, pet project log, message, my second entry, weather, partly cloudy. Let's hit enter. And we've created a structured log entry with the JSON format. Now let's check out the logs that we have in Cloud Logging. Let's type out G-Cloud logging read resource that type equals global. Let's hit enter. And as you can see, we have our logs here with the log name pet project log. Now let's view this using the logging viewer for a much better experience. Let's go to the Cloud Console and open logging, and we can see the viewer here. Let's filter to our log name, which is pet project log. And there, we can see the logs that we've sent here in the viewer. We can also see the difference between structured and the unstructured log formats. And that's it. That's how we write to Cloud Logging using G-Cloud, which is just one of the many ways to write logs. Now let's try out the built-in logging capabilities of App Engine. In line 6, we have a create a log endpoint, and in line 8, we write hello cloud logging to console.log. Now we've already deployed this app, so it's already running in App Engine and ready to serve requests. Let's make a request to our create a log endpoint using our browser. There, a log has been written. Let's see if we can find it in the logs viewer. Let's remove the filter and see all logs. There it is, hello cloud logging. As an alternative to using console.log, there are better logging libraries for Node.js like Winston and Bunyan that you can use for your application. If you want to look into the other methods as well, you can look into the Google Cloud documentation under Logging Libraries Overview. The Logs viewer is really all about one thing: logs. It's really all about the log entries, and everything else is about helping us find the specific logs that we are looking for to help us investigate and fix issues in our systems and applications. Let's talk about the log entries. Each row here is a single log entry. We can click it to expand and show more details. We can expand it further by pressing Expand Nested Fields, and that will show us all the fields. We can also copy to the clipboard if we want. Now it's a bit time consuming if what we are looking for is inside this log entry. So, we can move fields to the summary line by just clicking it and pressing Add to Summary Line. This will allow us to see patterns easier and quickly spot what we are looking for, even just by scrolling through the entries. Now, there could be millions of log entries in here, and we really want to find a few specific log entries. The filtering tools in the Logs viewer will help us find the logs we are looking for quickly. First, we have the Query Builder. This allows us to define our query for our log entries. Let's try setting the resource to our Google App Engine application. And the severity, let's set it to all. Let's press Run Query to run it. Up next, we have a time filter which we can use to set a constraint on the time. We can set a time range like the past 6 hours, for example. This is where the histogram can become really useful because it can show us the frequency of logs throughout the time range. So the taller bars here mean that there are more logs that match our query during those times, while the smaller or empty space means few or no logs match our query for those times. We can click on one of the bars and press Jump to Time. This will change our time range and filter the log entries to that specific time in our query. Our histogram has also reloaded to zoom into our new time range and show a new histogram across this new time range. Now on the left side, we see this Logs Field Explorer. This basically shows a summary of the fields and the number of log entries that match them. Say if we want to filter our logs to just the errors, we can simply click on Error and it'll adjust the query in the query builder and rerun the query automatically for us. This will filter the number of logs further down and really help us track down the specific logs that we want to find. Now, if we need more reading space, we can close the Logs Field Explorer and even the histogram, and even minimize the sidebar. If we want it back, we can just press the Page Layout control over here and enable our Logs Field Explorer and histogram again. And that's it! Mastering the Logs Viewer will definitely help you track down those bugs faster. Google Cloud Debugger is one of the coolest tools in Google Cloud. It's a service that lets us take debugging snapshots and inspect the state of our application variables, even if it's serving live traffic. This is really useful when trying to debug issues that are not easily reproduced locally. Okay, let's try it out. Over here, I have an application that is deployed to App Engine and is serving traffic. For this demo, it just says hello, but behind the scenes, it does something more than just print out hello. Let's open Cloud Debugger in the Google Cloud Console and check out what our code is actually doing. Now for this demo, we are using App Engine, but Cloud Debugger works with other GCP environments as well, like Compute Engine, GKE, Cloud Run, and even VMs running elsewhere. Once we're in the Cloud Debugger page, the first thing it's going to ask us is to load the source code of our application. Now there are many ways to load our source code. We have all these options over here. But since we're using App Engine, it's already loaded for us. We just have to double check that the version is the currently serving one, and it's usually the version that has a tag 100% on it, which means it's getting routed 100% of the traffic. To start, we select the file that we want to debug. In our case, it's app.js. Let's take a look at what this code is actually doing. As you can see, we have this array of letters that spell out hello. But in order to formulate a response, we loop through it and concatenate each letter to the response variable, which we then finally send to the user in line 21. What a creative way of saying hello! But we are just using this to showcase what Cloud Debugger can do. Right now, we can't really click around here because the Cloud Debugger is not yet active. We have to press this check button over here for Cloud Debugger to try to sync up with our code and activate. There, now it's active. So as you can see, this is our code that's currently running. And we can add a snapshot trigger at any line number that we want. To add a snapshot, we click on the Snapshot tab. Then we can click on line number 16 over here. Then Cloud Debugger is going to take a snapshot of the call stack and the state of the variables at that point in the code, but only starting on the next request. So let's go back to our application and make another request. Now to make it easier for us, let's simulate user traffic using this auto-refresh extension that basically refreshes this page every 5 seconds, so that we don't have to do this manually every time. Let's go back to Cloud Debugger, and there's our first snapshot. As you can see, the variables are here, as well as their values, and also the call stack. Now this only shows us the first pass of the for loop. What if we want to see the second pass? In this case, when I is equals to 1 instead of 0, we can add a condition to our snapshot. Let's make it I is equal to 1. And let's wait for our snapshot to hit again. And there we have it. We have the state of the variables when I is equal to 1 at this point in the code. That's really cool. We can also add expressions like hello array I and press enter to evaluate that expression when the snapshot hits. This gives us the value of hello array I, which is E, because I is equal to index 1, which is the second value in hello array. Now what if we want to log each time the loop executes without having to manually set a condition each time? We can do that with log points. Let's click on the log point tab over here. And then let's select the line number of where we want to add the log point. In this case, we want to add it to line number 16 as well. A log point has two parts. The condition, which is evaluated in the syntax of the source code. Since we want to log this all the time, let's just keep it to true. The second part is a string, which has a curly brace expression that is also evaluated in the syntax of the source code. Let's make this the value of response is curly brace response curly brace. Let's add it. Let's go to the logs to see our logs come in. And there we go. We are adding logs to our running application deployed in the cloud without having to change any source code. That is amazing. And that's it. Cloud Debugger can be really useful for figuring out the root cause of issues, especially when they happen only in deployed applications. Alright, let's learn how to use Google Cloud Trace to find performance issues and bottlenecks in our application. This is the Trace service in the Google Cloud Console. The first thing we see is this overview page. There's a lot of information here, but we're going to break it down one by one. Over here, we have the Insights section, where Trace provides us with tips on how we can improve our application, if there are any. Then, we have the Recent Traces over here, which shows the most recent traces that has been sampled from our application. Trace doesn't analyze every single request to our app. Rather, it samples a subset of requests and then displays the most recent ones here. Up next, we have the most frequent URIs. Now this is important information for us because these are the URLs that are most used by our users. And we want to keep the latency on these URLs as low as possible to give our users the best experience. So if we see any high latency URLs here, then that would be the immediate focus for optimization. Next, we have the most frequent RPCs, which are app calls. Then, the chargeable trace spans, which give us information on how much trace spans are being billed for this project. There is a generous free tier for the first 2.5 million trace spans, so for a lot of cases, trace will mostly be free or low cost to use. On the right side, we see the daily analysis reports. This shows us a comparative report of popular endpoints and their latency compared to the previous week. This gives us information on whether our endpoints are performing better or worse over time. To go into more detail for each trace, we go to the trace list. Here, we are able to view all the traces and dig into the details of each one. We can adjust the time range to select a subset of traces. We can also filter by specific properties like minimum latency, status, version, and many more. Let's try taking a look at some recent traces that took some time. This graph is really useful because it can show us which requests have been taking the longest and quickly just browse through the high latency ones. Clicking on any of these also brings up that specific trace for us to be able to look into the details and investigate more. I can then look into each one and see the trace spans, so I know at which point in the application took the longest time. As you can see here, there's something going on with multiple calls to example.com. And there's also a gap between each call, like the code execution is pausing for a consistent moment between calls. Let's take a look at the actual code. In line 13, we have our weird endpoint. In line 15, we see the for loop. That explains the multiple calls to example.com. And in line 16, we have a sleep call for 1.5 seconds. That explains the consistent gap between executions. What a weird endpoint indeed. Now going back to the trace list, there are some more information that could be useful here. We can also view the entire log entry of this request in the logging viewer. This is useful for digging deeper into what might be causing latency issues. Lastly, we have the analysis reports page, which lists all the daily reports that are automatically generated for us. We can also create a custom analysis report for specific endpoints by clicking the Create a Report button here. Alright, that's how Trace helps us identify performance issues in our application and helps us prioritize which endpoints to optimize. In this video, we looked at traces of our App Engine application. However, we can also set up Trace to run in other environments even outside of Google Cloud.